In this lesson, we're going to talk about thermostats. Now, for central air conditioning, the function is to turn the system on and off automatically based on room temperature. Most of the thermostats you're going to see do not sense humidity. They are only sensing sensible air temperature. That's the temperature you can measure. They have to be located on an interior wall, and the closer to the return air vent is best. Okay, most are 24 volts, and this because of safety. We don't want anyone getting shocked if they stick something into a 120 volt thermostat. This is an example, just one example of a thermostat. This is a Honeywell. It's automatic, it's digital, it's programmable. The thermostats are made up of a sub-base. Okay, the thermostat mounts onto a sub-base. The sub-base has to match the thermostat because they have wired terminal connections that plug into the back of the thermostat. There's location for switches, and the sub-bases must be level on the wall. This is an example of a sub-base. You'll notice up around here there's some screws for the wire terminal connections. Okay, and these are the electrical contacts that actually connect to the back of the thermostat. Your switching devices in this case are from like the fan switch and the heat, auto cool, are all on the sub-base. This is another example of a sub-base. Again, this has your snap acting sensor right on it. Okay, your cooling and heating switches are on here. Same thing here. This is for one of the old Honeywell round thermostats. You'll notice your wiring connections, and the hole that's around the wiring connections here is designed to allow the wiring to come out of the wall and into the subbase. The thermostat mounts onto the top of the subbase. Okay, the thermostat component is where the temperature is sensed. The action will close a switch and turn the air conditioning system on. The indoor blower coil is energized in the air conditioning mode. So we have four types of thermostats. We have a mercury bulb, we have a bimetal or snap action, we have a helix coil, and we have solid state. And if you look on this slide, all of the pictures are here. Okay, we have our mercury bulb, we have our snap acting, and we have a helix coil, and we have a solid state. The solid state is the one you're going to start seeing most of in the field. Okay, all the terminals all have a specific function. Try as much as possible to use the correct color wire. However, that is not a necessity anymore. As we start getting into thermostats that are more and more complex, you're going to start seeing wires used that do not have the traditional green, yellow, white, and red. The important part is to make sure that the same color wired is connected on each side to the correct terminal designation. Okay, that's connected with thermostat rated wire, usually 18 gauge. However, more and more we're seeing Cat5 digital cable being used. Do not strip and expose too much copper at each end because it's very likely that over time the copper could end up touching each other and causing a short circuit. The terminals on thermostats, most of them, you have an R or an RC, that's the 24 volt from the air conditioning transformer. Traditionally, this has been a red wire, but that is changing. Y is your cooling contactor coil. Y2 is your second stage cooling contactor coil. G is your fan relay. O is a reversing valve specifically used in heat pumps. And if you ever go work in the southern part of the country, you'll also see a B terminal, as in boy. That is a reversing valve as well. RH could be the 24 volts from the heating transformer. If you have a separate RC, you'll see an RH. Normally those two are jumped together. W is your heating relay. W2 is your second stage heating relay. And C is a common or black. The C terminal, the W2, and the Y2, and the O you will not see on every thermostat. These are just some examples of the different thermostat wiring that's available. Okay, I would probably recommend saving these examples. They're in your handouts because they give you a good idea of what's wired to what and the functionality. The first one is a simple thermostat, has an R, Y, and a G. The second one adds a heating. The third one up here, again, allows a separate transformer because it has an RH and an RC, so it's a heat cool, but it does have a separate transformer for heating and cooling. The left one on the bottom row adds a W2, so it has two-stage heating. And you'll notice H1 is here, that's your first stage heating, but they've just labeled it separately. This is the, oh, and this has a heat pump. It has the B terminal, which is a reversing valve. The middle one, R, W1, W2, Y1, and Y2, has two-stage heat cool, slightly more expensive but higher grade system. And then the third one on the right is a standard heat pump system with backup heat, has an O terminal. Now, digital thermostats work the same way as the non-programmable thermostats. They're more sensitive and more accurate. They have a time delay built into them that delays the compressor from starting. If the pressures are not balanced, the compressor will trip on the overload. So that time delay can be up to a 5-minute time delay to make sure the compressor doesn't cycle too fast. Most of them have a battery backup to store temperature settings. This is an example of a digital thermostat. Okay, if you look real close in all digital thermostats, you'll see a thermistor. That's the temperature sensing element. It's usually near a hole or some opening in the thermostat to the outside or to the room air. Programmable thermostats make the system completely automatic. If programmed properly, the programmable thermostats will save money. Each thermostat is a little bit different. Most have information on the inside of the cover. You have some basic settings and 4 functions: wake, leave, return, and sleep. So you can actually change the temperatures based on what time of day it is and the functionality. Okay, this example basically says you have a wake up time where the thermostat comes up to 70 degrees. As the house is empty while people are at work and school, the temperature drops. And then by the time they come home for the evening, the temperature comes back up. And then overnight, the temperature drops down for sleep. However, as you're looking at this program, you need to be aware that if you drop the temperature of a house 10 degrees over the course of the day, all the plaster and everything in the house, everything in the house is also cooling off 10 degrees. It is very likely it can actually cost you more money to heat everything back up than to keep it at more of a steady temperature. So be very careful with how far apart you program the digital programmable thermostats. 10 degrees is an awfully large temperature swing, especially in a colder environment. Programming a thermostat, it's all basically the same. 5-day, 2-day, 7-day, 7-day each with a different time period. Okay, you can also switch over to a manual or override mode. The override can last 2 to 3 hours or until the next scheduled program, or you can click the override again and make it permanent. Okay, all of them have a 5 to 8 minute time delay for air conditioning. Most will not have a time delay if the air cooling has not run for an hour. In other words, it keeps track on how long the cooling hasn't run for. Again, the purpose is that we don't short cycle that compressor. Okay, these are just a few pictures of the linkages that I talked about earlier. This is a snap acting. Okay, the parts of the snap acting, but specifically we're worried about this component there. This again is the Helix. Okay, how your wire comes into the Helix and it has a snap acting. This has a magnet that actually is what causes the snap to occur. This is a mercury bulb thermostat. Okay, you can actually see the mercury with the 3 wires. The reason it has 3 wires coming in is it is a heating and cooling thermostat. One is common, that's going to be your R, the center one. And then you'll have two other ones based on whether or not it's in a heating or cooling mode. Okay, so again, the mercury bulb. Important part about a mercury bulb is don't break them. They have to be environmentally safe disposed. Another closer picture of a snap-acting thermostat or a Helix snap-acting shows you the anticipators on it as well. Okay, couple different wiring diagrams. Okay, this is a cooling only. Okay, cooling relay here. This is the thermostat open. Okay, a cooling thermostat opens as the temperature drops, so it's always on the bottom. Then here we have the cooling that's calling for heat. This is in its energized position. And the anticipator used in a cooling thermostat is a fixed resistor. It is not adjustable as you would find in a heating system or in a heating thermostat. And the resistor is only operational when the thermostat is in its off cycle. When the thermostat is calling, the anticipator is actually bypassed because voltage and current will flow the path of least resistance, which is in your thermostat. In a window air conditioner, in a package unit, specifically window, you will find the thermostat to be a remote bulb thermostat, remote sensing element, and it will actually be in front of the incoming air, so the return to the system. It will be right behind the cover.